Good afternoon. This is the video study guide for ES10 Oceans. The first thing we're going to talk about is ocean floor formations. You need to be able to label a diagram of these. And so I'm just going to draw this two-dimensionally for the most part. And I'll label the features one at a time after it's drawn. And my continental shelf is going to be on both sides, and this one's a little more three-dimensional. Starting on the left here, we've got land, and then a shallow area under the water called the continental, I'm abbreviating there, shelf. This steep area is called the continental slope, and the very beginning of this whole area where it just barely starts to rise up is called the continental rise. All of these things together are called the continental margin, and it is formed by erosion and deposition of continental materials. So rocks get weathered and eroded, the sediments get carried by rivers down to the sea and dumped off, forming this big pile, which is the continental margin. Underwater mountains are called seamounts. They would be formed by plate tectonics, also abbreviating here. This here is the mid-ocean ridge. It is a divergent plate boundary. So I'm drawing some arrows there to show you what direction those two tectonic plates are moving away from each other. That's a divergent boundary. That is also where new ocean floor is created, and sometimes it's called a spreading center. The area in the middle there would be called your Rift Valley, two L's in there. And on either side of that would be kind of a mountain range. And this mid-ocean ridge goes all over the globe under the water. Almost every ocean has one in the middle, and where new ocean floor is created. This seamount with an eroded flat top, this is called a guyot, and that is formed by the erosion of a seamount. So in order to have erosion of a seamount, you have to have a seamount first. So a guyot is formed first by plate tectonics and then erosion. This very deep area is called a trench. A trench happens at a convergent plate boundary. And it's also sometimes called a subduction zone. You have two tectonic plates colliding together, converging, and one is sliding underneath of the other one. And that's why it's called a subduction zone. This part that's reaching the surface, that would be called an island. Sometimes you might see island arc, sometimes you might see volcanic island, but if it's reaching the surface, it's an island. Then on the other side, you have a continental rise, continental slope, and continental shelf. Again, if there is a place where a river has cut through the continental margin, it's called a submarine canyon. And I like to say that's formed by an ancient river. There's one thing that I'm missing that I'm going to share with you. That is any flat part of the ocean floor is called the abyssal plain. So most of these features are either formed by erosion or plate tectonics or some combination of the two. For the plate tectonics part, it's good to remember that there are three main types of plate boundaries. There's divergent, there is convergent. Convergent is coming together. And then there's one more that's called a transform plate boundary. And we'll do a whole unit on plate tectonics, but these are the three major types of plate boundaries to know. Another important thing that happens in the ocean is called convection. Convection can happen in any fluid, a liquid or a gas, and that's when less dense material rises and more dense material sinks. So in the ocean, if the water is denser, it can either be colder or saltier. So you have your cold, saltier water, more dense water sinking, and your less dense, warmer water rising pretty much at all times. What this sets off is something called thermohaline circulation. Now I'm going to draw really like an extra cruddy world map here. Here's the United States, and Canada's got some stuff going on up there, and then there's Greenland and Iceland and Great Britain. Then you got Europe and Scandinavia, kind of like that. Then Africa's pretty big, and then you got Asia, which is even bigger, and then down here is Australia and a bunch of islands, including Japan, and then a bunch of really tiny islands too. So this is not to scale, obviously. This is my map that I'm going to draw some ocean currents on. I'm going to put Antarctica down here. So, because of this convection, ocean water is moving all over the place all the time. And you have some currents moving along the equator, some currents moving sideways down here at the Roaring Forties, kind of in both directions here. You have these gyres, which are big circular ocean currents. In the center of the gyre is an area of calm water. And so, probably the most important thing to know about these ocean currents is that there are warm ones and there are cold ones. Well, after you memorize the fact that they're started by convection and density differences, then you need to know there are warm ones and there are cold ones. So based on what we know about the distribution of heat on planet Earth, the stuff at the equator is probably going to be warm. And the stuff that's closer to the North Pole and the South Pole is generally going to be colder. But then you have these currents that are moving either toward the equator or away from the equator, like the Gulf Stream. The Gulf Stream moves from warm water in the Gulf of Mexico up towards Europe, and it turns into the North Atlantic Drift, and it carries warm ocean water up towards Europe, and the sun's energy is being carried up towards Europe. And that makes cities that are in Great Britain or Scandinavia a little warmer than you might expect because they're benefiting from this warm ocean current. Other currents are moving away from the poles and towards the equator. So this California current is cold. It's moving from a polar area towards the equator. It's carrying cold water into a warmer area. In cities that are near the coast there are experiencing a cold current, and they're a little cooler than you might expect. So if a current is moving away from a polar area and towards the equator, it's a cold current. If it's moving away from the equator towards a colder area, it's a warm current, carrying that solar energy to other parts of the world. And this is called global thermohaline circulation. Sometimes it's called the global conveyor belt. It's moving the sun's energy all around, and there's more currents than the ones I've drawn here, but you get the idea. All these currents also tend to curve, and their curving is due to something called the Coriolis effect, which is a fancy way of saying the Earth is spinning, so the currents curve. Wind currents also do the same thing. It's also important to know that a gyre is a large circular current, and an eddy is a small circular current. All right, I'm going to stop this now and do part 2.